All right, so let's try our practice at graphing and finding out how to build the rectangles and what the shells are looking like. So x equals 0, looks like this. X equal 2 is here. And then you know that y equals 0 is this. All right, so identifying the area bounded is in here. And so if I'm revolving it about the y-axis, so let's just make sure we can understand why drawing rectangles perpendicular to the axis of rotation is not a good choice. Because the top function changes. Here it's the blue, x equal 2. Here it's the red, y equal e to the negative x. So those are not good choices. We'd have to make two separate integrals. So let's build our rectangles parallel to the axis of rotation so that we can see the shell. Okay, so the radius of our shell here is x. The thickness of the rectangle that I'm spinning is dx. So volume by shells is 2 pi, radius, height, and then the thickness of my rectangle. So the radius is x, because I'm revolving it about the y-axis. This distance here is the radius x. The height is the height of this rectangle right here, and that goes to the function e to the negative x. Where am I building rectangles from and to? From 0 to 2. All right, let's look at this next one. Y equal root x. That's that graph. X equals 0 is here. And then we have y equal 2 minus x. So it looks something like this. All right, so identifying the area that's bounded is this area here. Be careful you pick the right one. And I'm revolving that about the y-axis. So this is center. So if I'm drawing rectangles parallel to the axis of rotation, that would be better than if I drew them perpendicular. Can you see that the top function would change again? That is not good. I don't want to do perpendicular to have to do extra work. So if I draw them parallel to the axis of rotation, I get a shell. So I see the volume would be 2 pi. Again, the radius will be x, because the distance from the center is x, depending on where I'm building the rectangles. The height of this rectangle will be top minus bottom. The top will be touching the red 2 minus x. The bottom will be touching the root x. Dx integration, and then I have to find out where they intersect. So 0 and where they intersect. So 2 minus x will run into root x at 1. That one more is looking at it and thinking about it rather than algebraically solving it. So 0 to 1. All right, so let's do another one here. E to the negative x, looks like this. Y equal 1, crosses at that point right there. And then x equal 2 is here. So this is the area bounded. And again, I'm revolving it about the y-axis. So let's draw the rectangles parallel to the axis of rotation. Again, I can see the radius will be x, so the volume will be 2 pi x, and then the height of my rectangle will be top subtract bottom. So the top function is the y equal 1, subtract the bottom, which is e to the negative x, dx. And I'm building the rectangles from x equals 0 to x equal 2. So this actually could be done in the other way. So let's just check it out just to have practice. So here's y equal e to the negative x. Here's y equal 1, x equal 2. So again, if I'm spinning it around the y-axis, I could draw rectangles perpendicular to the axis of rotation. So it would look like this. So perpendicular, I see that it gives me a washer, so squared minus squared, and I can see that it's dy integration. So the outside radius goes all the way out to x equal 2, so that would be 2 here. The inside radius is from here to the blue function, which is y equal e to the negative x. So I want to solve y equal e to the negative x for x equal. So ln of y equal negative x. So negative ln of y is x. So that is what the inside function is. And then I have to figure out where on the y-axis I'm going to be building rectangles from and to. I can see I'm going to end building it at 1, but I have to find out what that y value is, where e to the negative x hits x equal 2. So I'm just going to be putting in x equal 2 into e to the negative x, so I get e to the negative 2. All right, one last one here. Y equal x squared plus 2. Parabola shifted up to x equals 0 here, and x equal 1 here. And then I've got y equal x looks like this. All right, so the area that's bounded is this, and I'm revolving it about the x-axis. Revolving that about the x-axis. So if I tried to make rectangles parallel to the axis of rotation, I see different top and bottom functions. So drawing parallel rectangles is not a good idea in this case. So let's draw them perpendicular to the axis of rotation. Then they'll always have the same top function and always have the same bottom function. So I see I'm making washers. So let me set up the framework for washers. dx integration. So the outside radius comes from the x-axis all the way up to the x squared plus 2. And the inside radius goes up to the line y equal x. And I'm going to be building the rectangles to spin from x equals 0 to x equal 1.